Okay, so here in Geometry, Unit 3, problem number 90, we're asked to determine which of the following pairs of triangles are similar and explain our work. So for these first pair of triangles here, I noticed that I have two angles in one and two angles in another. But unfortunately, those two angles are not identical, so I can't right off the bat say they're similar by angle. But what I can do is find the third angle in this triangle and the third angle in that triangle, because I know all three angles in the triangle must add up to 180 degrees. So 180 minus 60 minus 40 ends up being 80. And over here, 180 minus 60 minus 85 ends up being 35. So what we notice is that the three angles in one triangle are different than the three angles in the other triangle. So these two triangles are not similar. Over here in the second one, we encounter a similar situation. I have two angles in this triangle, two angles in this triangle that don't match up quite yet, so let's find the third. So 180 minus 50 minus 45 gives me 85, and then 180 minus 50 minus 85 gives me 45. And what we notice here is that, yes, the angles do match up. We have 50 and 50, 45 and 45, 85 and 85. So yes, these triangles are similar by angle similarity. And we notice the proportion works as well. 6 is to 4 is 9 is to 3. That's a 3/2 proportion there as well. So you could also say well, I wouldn't go that far, but we definitely say they're similar by angle similarity. The sides don't necessarily match up. The 6 and the 9 don't match up with the 6 and the 4, so I wouldn't jump to those conclusions, but there is a nice ratio here between the sides as well. The 6 and the 4 do match up, so we can create a proportion that way. The last one here, we got to see if there's a side proportion, since we don't know any of the angles. And so we may have to do a little bit of trial and error here, because we don't know which side this 6 matches up to. I'm going to take a stab and say 6 matches up to 12. It's a 2-to-1 ratio, right? 12 is twice as big as 6. So if that's true, and 6 really is proportional to the 12, then there should be a 2-to-1 ratio for the other sides as well. When we multiply 7 by 2, guess what? We get 14. Multiply 18 by 2, guess what? We get 16. So I would say that yes, these are similar by a side proportion of a ratio of 2-to-1. So if you have angles, work with angles. If you have sides, work with sides, and determining if the triangles are similar or not. If you have questions on any of those, feel free to leave a comment. Otherwise, as always, you can subscribe, like, or share to our videos.